All right, now we are on composition of functions, and that we're told that f of x is negative 3x plus 1, g of x is 2x plus 4, and they asked me to find g of f. So I'm going to rewrite it. I would rather write it as g of f of x. The order is always the same. G goes first, f goes second. Okay? And then I write g, I start with the innermost parentheses, and instead of f of x, I write in negative 3x plus 1. Then the g function says take 2 times what's in the parentheses and then add 4. So 2 times what is in the parentheses plus 4. And then you do have to go ahead and multiply that out. So we distribute this. So this would be negative 6x, and 2 times 1 is 2, then plus 4. So the final answer would be negative 6x plus 6. All right, that is what our g of f of x is. Then they ask us to find f of g of x. So in this one I'll say f of, and instead of g of x I'm going to put in 2x plus 4. And then the f function says take what's in the parentheses, multiply it by negative 3, and then add 1. So I go negative 3 times what's in the parentheses, and then add 1. So this will come out to be, we'll just distribute this times this times this. So this will be negative 6x minus 12 plus 1. And then I just collect like terms. So final answer here would be negative 6x and negative 12 plus 1 gives you negative 11. So that would be our answer there. All right, our next little set of problems here. They tell me f of x is 4 over x plus 2, g of x is 3 over 2x. Now we're doing the same thing, just composition of functions. So we have f of g of x here. So this will be f of g of x, which is 3 over 2x. All right? And this is going to be equal to, then we have to put it into the f function. So everywhere they have an x here, I'm going to put 3 over 2x. So I have 4 over, instead of x, I put 3 over 2x plus 2. I'm going to go ahead and call it 2 over 1. I already know I'm going to have to combine these two things, and to combine them you need a common denominator. So to make 2x and 1, the least common denominator is 2x. So to make 1 a 2x, I'm going to multiply numerator and denominator by 2x. So that gives me 4 over, now my denominator is 2x, and the numerator of this bottom fraction is 3 plus 2 times 2x, which is 3 plus 4x. At this point, then you do your little, you're dividing two fractions. This fraction bar here really means divide by. So it's like you're saying 4 divided by 3 plus 4x divided by 2x. And the rule goes, dividing fractions easy as pie, flip the bottom and multiply. And so I have 3 plus 4x here. And this, the 4 is like over 1. So I just said 4 over 1 divided by 2x, 3 plus 4x over 2x. So dividing fractions easy as pie, flip the bottom and multiply. So now I can just multiply straight across. So this gives me 8x in the numerator. 1 times this will just be this. I'm going to put the x first, so I'd rather put the x first. So 4x plus 3. Now some of you might be asking, can we cancel the x's and call 8 over 4 2? No, you may not do that. These two are attached by addition, so you cannot just randomly cancel things. All right, let's do our next one. It says g of f of x. So we have g of f of x. So we have g of, and then f of x, remember, is 4 over x plus 2. And the g function says put 3 in the numerator, and in the denominator 2 times whatever's in the parentheses. They said 2x here because x is in the parentheses. So I'm going to say 2 times 4 over x plus 2. Remember, if you're dealing, it's 2 times this, so this is like 2 over 1. So now I have 3 over, 2 times 4 is 8, and 1 times x plus 2 is just x plus 2. Then I'm going to do my little division thing. Dividing fractions, easy as pie. Flip the bottom and multiply. So I just took this bottom fraction and I flipped it, took the reciprocal. And now I'm going to multiply these two things. I have to distribute. So 3 times x is 3x. 3 times 2 is 6. 1 times 8, 8. And there is our answer. You could factor 3 out at the top, but it doesn't help cancel anything in the denominator, so I would just leave it exactly like that.